Students, today we are going to learn application of derivative in that exercise 4.3. Before we start the exercise 4.3, we have to know the concept which is used in the exercise 4.3, that is maxima and minima. The word maxima is says the first three letters max. Max is nothing but a large. So in the function we have to find the maximum value which is in the graph. Now the second one, minima. In that the first three letters says as a mean. Mean is nothing but the minimum value, small value. So we have to find in this exercise how to find the function, whether it is a maximum or minimum. So first of all, we see about the definition of maxima. Maxima. Maxima is nothing but a function f is said to be maximum if f dash of a is equal to 0 and f double dash of a is less than 0. Now here f dash of a is equal to 0, that means the first derivative of the function at the point a is equal to 0. F double dash of a is less than 0 means the value of the function is always negative. The value of this function is always negative, that means less than 0. Then only we can say that the function is maximum at what point? So the function f of x is said to be the maximum at x is equal to a. So any point x is equal to a, that time we have to check the condition f dash of a is equal to 0 and f double dash of a is less than 0. Then only the function is a maximum. Now we see this in the curve form. If we draw the x-axis and y-axis, here x-axis, y-axis. If I draw the curve like this, then the function f of x, we write this curve as a function f of x. Now this is the extreme point. So this extreme point is called as a maximum point. And we have to find out this maximum point, whether the function is a maximum. Now I find that point here on the x-axis. I write any point a. So value of this function x is equal to a, that time the function is maximum. If we draw like this, another two line, this is x is nothing but a minus delta. This one in the x-axis, point a is given. After some distance, we write as a plus delta, like this. Now the second one we find as a minimum. Minima is nothing but a function f is said to be minimum, minima at x is equal to a, again some point a, if f dash of a is equal to 0 and another condition f double dash of a is greater than 0. That means if we put the value of x is equal to a on the any point on the curve, and that time the function first derivative of the function is equal to 0 and the another condition f double dash means the second derivative of the function is greater than 0, that means positive. You have to remember, when the value of the double derivative become positive, that time function is minimum, and the double derivative of the function is negative, that time we get maximum. So some students make a mistake in this too. When the answer we got less than 0, maximum function, and answer we get greater than 0, positive, that time minimum function. Now we see the graph of this function. Again, x-axis, y-axis. Now in this type, if the function is a minimum, that means it starts from max point and maximum to it decreases at a minimum and then it again start increasing. First, second, I increase the x-axis as a third point. Now we write a minus delta, a plus delta. Now the first graph, function is opposite action, small to increase and decrease. Now in this, it is starting from the maximum point and reduce. At this time, it reduced the last f of a, because this is a function f of x, and I put the value of a, it become f of a, and again it goes increasing at this point. We have to find out the minimum value. So smallest value of this function. Now how to find out the minimum and maximum value to the function? It has some steps that we have to study. Now procedure for finding maxima and minima. Remember this procedure. First step, step 1. Always write the given thing and then find f dash of x. F dash of x is nothing but the first derivative. In the procedure, we write the first given function f of x. Then we follow the first step, find f dash of x. F dash of x is nothing but the first derivative of the function, is also written in the form of dy by dx. The second step that we have to follow, find f double dash of x, that is nothing but the second derivative of the function with respect to x. This 2 dash is says as a second derivative of the function with respect to x. The third step we have to follow, find roots of the equation. Find the roots of equation, that is nothing but extreme value of x for the function. That time we have to use f dash of x is equal to 0. Step 4. If we get value of x, root of the equation, f dash first derivative is equal to 0, we consider. From that we solve that equation and we get the value of x. If we get the value of x, after this step we have to put this value of x in the another function. If value of x is equal to a, then this value we substitute in the second equation, that is nothing but we put in f double dash of x. So it become f double dash of a. If we get the value of f double dash of a, the main step, step number 5, this step is very important because this step is decide whether the function is a maximum or minimum. If f double dash of a is less than 0, then f has a maximum at x is equal to a. We have to remember maximum, that time less than 0 means negative value. And second thing is, if f double dash of a is greater than 0, then f has a minimum at x is equal to a. To find the value of maxima and minima, again we substitute the same element x is equal to a in the original function. Step 6. In this step 1, 2, 3, 4, it's the same method to find out the maximum, whether it is a maximum or minimum. To find the maximum value at that point, fifth step is necessary. And the last one, if you have to find out the maxima or minimum value, maximum or minimum value, that time find f of x at x is equal to a. That means in the original function, that is given function, in that we substitute again the value of x is equal to a. So this is a very easy procedure to find out the maximum and minimum. Now we start the exercise 4.3. Exercise 4.3, question number 1. Determine the maxima and the minimum value of the function. 3 questions are given. In that first one, f of x is equal to 2x cube minus 21x square plus 36x minus 20. And remaining the two sums. First question we solve. Given the function f of x is equal to, we write first step that we have to solve. First step to find out the maxima and minima, that is nothing but find f dash of x. F dash of x is nothing but the first derivative of the function. Okay, this we have to find out. So differentiate with respect to x. We differentiate the function with respect to x, then only we get the f dash of x, first derivative of the function. So we write here 2 derivative of x cube. We use the formula n into x raised to n minus 1. 3 into x raised to 3 minus 1 is 2 minus 21. Again derivative of x square 2x plus 36. Derivative of x is equal to 1 minus derivative of 20 is equal to 0. Because 20 is a constant number, so we get the derivative is a 0. Now simplify the sum. 3 2s are 6x square minus 21 2s are 42x plus 36. Step 2. Find the double derivative. So again differentiate with respect to x, because we have to calculate the double derivative of the function, that is nothing but the f double dash of x. The second derivative, again 6, derivative of x square is 2x minus 42, derivative of x is equal to 1 plus 36 is a constant number, so derivative of the constant number is equal to 0, is equal to 6 2s are 12x minus 42. This is the value of second derivative. Now the next step is step number 3. We have to find out the value of x. For extreme value, we have to consider f dash of x, that is nothing but the first derivative of the function, is equal to 0. So that is first derivative of the function is what? 6x square minus 42x plus 36 is equal to 0. Okay, so from this we can take 6 is a common number, so therefore 6 x square minus 6 7s are 42, 7x plus 6 6 are 36, 6 is equal to 0, because from this whole equation we take the 6 common. Now 6 in a multiplication, convert this side in a division. So 0 divided by 6 becomes 0. So x square minus 7x plus 6 is equal to 0. Now this is a quadratic equation. So quadratic equation always give the two answer or two roots of the equation. X square minus 6x minus x plus 6 is equal to 0. Now see here. Minus 6 multiplied by minus 1. Minus 1 into minus 6, it gives plus 6. And minus 6 plus minus 1, it gives minus 7. So this is the factor of the equation. Take x common from this two. So x minus 6, take a minus 1 common, x minus 6 is equal to 0. Therefore, write the factor x minus 1, x minus 6 is equal to 0. Therefore, x minus 1 is equal to 0 and another factor is x minus 6 is equal to 0. We get x is equal to 1 or x is equal to 6. Now the step 4 is substitute the value of x in step 2. That is nothing but we have to put the value of x in f double dash. For x is equal to 1, we write f double dash of x is equal to f double dash of 1. So we substitute this value f double dash of 1. The function is given 12 in a bracket 1 minus 42, because we have the function f double dash of x is equal to 12x minus 42. So replace the value of x by 1. So 12 minus 42 we get minus 30. Minus 30 is a less than 0. If the value of the function is a less than 0, then we call this is a maximum function. So here we write the function f of x attains maxima at x is equal to 1. Now we have to find out the maximum value of the function. Now we find out step 6, maximum value of at x is equal to 1. So whenever we have to find out a maximum value, that time we have to put in the original equation f of x is equal to 2x cube minus 21x square plus 36x minus 20 is equal to 2. 1 cube is 1 minus 21, 1 square plus 36 into 1 minus 20. Solve this, hold the terms, we get the answer 2 minus 21 plus 36 minus 20 is equal to 36 minus 20, 16 minus 21 plus 16 is equal to minus 5. 2 minus 5 is equal to minus 3. So minus 3 is a maximum value at x is equal to 1. But in this quadratic equation we get x is equal to 1 as well as x is equal to 6 also. So now we again solve from the step number 4 for x is equal to 1. Instead of we put x is equal to 6. Again we start step number 4 for x is equal to 6. After this, in x is equal to 6, we put in the f double dash of x 12x minus 42. Put that value 12 into 6 minus 42. 72 minus 42. It gives answer 30. 30 is greater than 0. Therefore, f of x attains minima at x is equal to 6. Now minimum value is f of 6. Again we substitute in the original equation. F of 6 is equal to 2x cube minus 21x square plus 36x minus 20 is equal to 2. 6 cube minus 21 6 square plus 36 into 6 minus 20. 2 into 6 cube is equal to 2. 1 6 minus 21 6 square is 36 plus 36 into 6 minus 20 is equal to 4 multiplied to 216, we get the answer 432 minus 21 multiplied by 36, 756 plus 36 minus 6 is nothing but the 6 cube, and 6 cube is 216 minus 20 is equal to 628. I add these two minus 756 is equal to minus 128. Now we get the value f of x 6 is equal to 1 minus 128. 8. So we write the last line. The function f of x has maximum value -3 at x is equal to 1 and minimum value -128 at x is equal to 6. Next, second sum we have to solve. Given function f of x is equal to x into log of x. Again we solve step number 1. First derivative of the function f dash of x is equal to, written this is x into log of x. So u into v rule we have to apply. Written the first derivative of second plus written the second derivative of first. X, derivative of log of x is 1 upon x plus log of x into derivative of x is 1. Numerator denominator same term cancel. 1 plus log of x. This is a value of f dash of x. Now again step 2. We have to do the again derivative with respect to x of first derivative of the function f dash of x. So f double dash of x is equal to derivative of 1. 1 is a constant term. So 0 plus derivative of 1 upon log of x is 1 upon x. So we get value 1 upon x. Now we have to find out the next step 3. Step 3, for extreme value of x. For the extreme value of x, we have to find out f dash of x is equal to 0. But f dash of x is 1 upon log of x is equal to 0. Therefore, now this plus 1 converting this side is a minus. So log of x is equal to minus 1. We write this log of x in the base e is equal to minus 1 because this is a natural logarithm. Now we convert this logarithmic form in an exponential form. You already study in the function chapter in the 11th standard how to convert the logarithmic function in the exponential function. So in an exponential form, x is equal to e raised to minus 1 because we have to calculate the value of x only. But here we get the log of x to the base e. In that we have to only find the value of x. That's why we convert this logarithm to the exponential form. Now e raised to minus 1 written is a x is equal to 1 upon e. Now the step number 4 that we have to find out f double dash of x. So f double dash of x is equal to f double dash of 1 upon e. And the function is 1 upon x. So we get the 1 upon e. Again, numerator, denominator goes to reverse in the numerator. E, value of e is always 2 point something. So value of e is equal to greater than 0 is equal to 1.7373 like that. So therefore, f is minimum at x is equal to 1 upon a because it is greater than 0. So function is a minimum. And the minimum value we have to find out is f of 1 upon e, that we find f of 1 upon e. The function is x into log of x, correct? So instead of this x, we write 1 upon e. So 1 upon e into log of 1 upon e. Now 1 upon e we kept as it is, and there is a one rule in a logarithm. Log of m upon n is equal to log of m minus log of n. So log of 1 minus log of e. We know that the value of log of 1 is equal to 0 minus value of log of e is always 1. So answer we get minus 1 into 1 upon e minus 1 upon e. Now, if we get the minus 1 upon e, there is only one answer. Therefore, F has only minima. Only minima. F has no local maxima. Now in this question number 3 is a remaining. Solve your own. Try it at home. Now the next some example exercise in that second one question is divide the number 20 into 2 such that their product is maximum. So we have to find out the equal two parts of 20 or some parts of 20. So 20 we can divide in two parts, but we don't know the actual two parts of this sum. So we consider the first part is x. So obviously another part is 20 minus x. First part is x. So second part we have to find out. It is obviously 20 minus x. If we write x into product, we have to find out. So x into 20 minus x, then equation we get x into 20, 20x minus x into x, x square. But if we consider one part is in another type, then we can use the another equation also. But now we get this equation, and this equation we have to solve. So we start. Let the two parts be x and 20 minus x. Therefore, f of x is equal to x into 20 minus x, 20 into x, 20x minus x into x, x square. Now, we get the function f of x. Then we follow the step number 1. That is nothing but we have to calculate the derivative. That is first derivative of the function. That is nothing but f dash of x. 20 derivative of x is 1 minus derivative of x square is 2x. So we get 20 minus 2x. Again step 2. Again differentiate with respect to x, means double derivative of the function. So derivative of 20 is 0 minus 2, derivative of x is 1. So we get minus 2. Step 3. In that step 3, what we have to find out? Extreme value. So for extreme value, f dash of x is equal to 0. So therefore 20 minus 2x is equal to 0. Therefore 20 is equal to minus, we write over here 2x. So x is equal to 10. We get the value of x, but in the sum they said that such that their product is a maximum. That means we have to find out the whether the function is a maximum or minimum. So for that we have to solve the state number 4. That decided the function is a maximum or minimum. So we substitute in a double dash of x is equal to double dash of 10. Double dash derivative is minus 2. Minus 2 is a constant number. So I get minus 2 and it is less than 0. If f double dash of is less than 0, then the function is maximum. Therefore, we can find out the product of this sum. So product f of x is maximum when x is equal to 10. Hence, two parts of 20 are x and 20 minus x. So x is equal to 10. Therefore 20 minus x is equal to 20 minus 10 is equal to 10. So we get first part x is equal to 10 and second part is also 10. Thank you. The another two sums remaining that you trying to solve your own. If you have any doubt, then we solve this sum afterward. Thank you.